is kind of the last shortcut that you guys are introduced to in order to differentiate, right? So we have power rule for differentiation, we have product rule, we have quotient rule, and now chain rule is going to allow us to differentiate any given function, okay? So chain rule requires us to look at a function and see it as being a composite function. Remember, like in pre-calculus when you guys talked about composite functions, like creating functions from other functions, like you guys created functions from adding, subtracting, multiplying, dividing, and we've had to use that in order to look at a function and be like, oh, I can apply this limit property because the function can be thought of as a sum of two functions, or in order to differentiate this function, I have to look at it and see that it's a product to know that I would use product rule in order to differentiate. Or, oh, this function is a quotient of two functions, so you would have to use quotient rule in order to differentiate. So chain rule is whenever you're looking at the function and you see a function inside of another function. Okay, outside function, inside function. And we're still going to be using those other rules that we've previously talked about. There are two different notations that you have to be familiar with for chain rule. This first one is useful in very specific situations, and I'll point those situations out as we kind of come along and cross them. Like especially, there's certain like related rates problems that will come up, which is an application of implicit differentiation, which is just lots of chain rule. Where using this Leibniz notation comes in really handy and can make the problem a lot nicer. Like I can think back to Arjun Calc was 2023. Like I remember there was a problem, one of the free response questions on their exam. It was so much easier if you recognized you could use this notation. But again, I'll point it out. It's something to be aware of, but it's not necessarily like what you're thinking of when you're thinking chain rule. The other notation, the prime notation, is what you usually think of like whenever you're applying chain rule, okay? But to explain the Leibniz notation, so if you are trying to find the derivative of a function that you can think of as being composed with another function, you can think about like decomposing those two functions, where you would have y is equal to f of u, f being the outside function, and then u being equal to g of x, which is the inside function. And then if you take the derivative of y with respect to u and the derivative of u with respect to x, and you multiply those derivatives together, then the du's can cancel, and that gives you dy over dx. Remember, with the Leibniz notation, like I would read this as derivative of y with respect to x. dy over du is derivative of y with respect to u. du over dx would be derivative of u with respect to x. So something like this, like first of all, this is a polynomial function that you technically like brute force could multiply it out and just use power rule. Okay, but I'm giving us kind of a simple example of where we could use this Leibniz notation. So if we were to think about not multiplying this out, and instead thinking about letting u equal to the inside function. So we have outside function and inside function. So letting u equal to x squared minus 4. And then y equals to u cubed. Do you see how if you were to substitute this in, that it would be this function? Yeah, okay. So this is u in terms of x. So if we differentiate u with respect to x, that's du over dx. What's du over dx end up being using power rule? 2x. Okay. And then we have y in terms of u. which means that dy over du would be 3u squared. Okay, so going back to that definition, dy over dx is du over dx times dy over du. Did I switch the order? Here, I switched the order, although it doesn't matter. I'll switch it so it's the same. They have dy over du times du over dx. So dy over du would be 3u squared. Du over dx is 2x. And then if we substitute what we had let u equal to back in, that was x squared minus 4. Okay, that's your derivative, or you could clean it up a little bit if you want. But that would be dy over dx. Using chain rule from the Leibniz, like with the Leibniz notation. Leibniz. Again, probably not how you're going to think about chain rule.
Is this the same thing with the dy over dx with f of x, where it's going to give you the same answer?
Say that one more time.
This is like if you take dy over dx of a function and take f prime of x the same function, aren't you going to get the same thing, right?
I don't know if I follow what the question is.
Wait, this is completely unrelated to
This
chain
is
rule.
if this function was named f of x, so this is using the dy over dx notation versus the function notation. So this next one, this is using the prime notation, which uses function notation. I think this is what you're asking. Where if you think about your function as being a function inside of another function, this is what I say to myself when I'm applying chain rule, okay? Derivative of the outside function, you leave the inside function alone. Are you on chain rule right now? Join me.
Yeah.
Thank you. Derivative of the outside function, leave the inside alone, times the derivative of the inside function. Okay, so derivative of the outside, leave the inside alone, times the derivative of the inside. Is this the more familiar one? So going back up here, I'm going to show you using that notation, like dy over dx. And I already have it, right? Outside function, inside function. So derivative of the outside would bring the 3 down, subtract 1 from the exponent. Leave the inside alone, and then times the derivative of the inside in this case would be times 2x. Right, which is the exact same thing that we had before.
So then how did Arjun used it as a...
Oh, no, I'm saying that this approach here, there are times that you might be given one of these rates of change, and I'll point it out as it comes up. It's being familiar with this notation. This is not normally how you think about chain rule. This is usually how you think about chain rule. But this is an alternative notation that can be helpful in different places.
Physics jump scare.
Is it?
Yeah, that's what we get on the cheat sheet. So I had to figure out what that means.
Oh, okay.
Yeah.
Yeah, because it might represent a different rate. If you're
I was trying to figure that out.
dv over dt, right? The rate of change of velocity with respect to time. Let's say that you're given I don't know. like dv over dx
Maybe the position
and
just
dx over dt. Yeah, the rate of change of position. Like let's say you're given velocity. I don't know.
Wait, don't you need to do that for absolute value? In which case it's like square root. Square root of x squared. Like that's just the absolute value, right?
Oh,
guess you
you
could do that.
to find the derivative of
Yeah, I
it?
guess
Yeah,
you
use a
would
little
do
chain rule. You totally could.
Yeah, there you go.
Okay, so something like this is not something that you previously could have differentiated using any of the other shortcuts, right? This isn't a power rule situation. It's not a function that's a product of two functions. Like you have to use chain rule. So it can be helpful for some of you. For myself, I know I always end up rewriting the radical in its exponent form. I feel like my minimalists who like to put the least amount of pencil to paper, like kind of avoid that and like, that's cool, you do you. But I usually like to rewrite the radical in exponent form. So then I can think outside function, inside function. Okay, so dy over dx, or which is the same as y prime, talking through it, and I find it helpful to talk through it. I encourage you to do it if it's helpful to you. Derivative of the outside, leave the inside alone, times the derivative of the inside would be 3. And then you guys know I don't like negative exponents, so just getting rid of the negative exponents. And if you want to go back to the radical, you can. It would really just depend on like what type of question's being asked, whether it's multiple choice. If it's free response, it wouldn't matter, but you know I don't like negative exponents. Are we doing okay so far, you guys? Yes. Okay. Now, in the last two examples where I took you through finding the derivative, kind of thinking this prime notation and talking through this process, didn't it feel like we were very much using power rule? Like derivative of the outside, we used power rule to find the derivative of the outside function. Leave the inside alone times the derivative of the inside. For algebraic functions where you have to use chain rule, that can also be thought of as applying the general power rule. General power rule is just chain rule, but it's like a special case of chain rule. It's kind of, so all general power rule is chain rule, but not all chain rule is general power rule. When you are differentiating algebraic functions and you're using chain rule, it's for general power rule. You're like applying general power rule. But chain rule can be thought of in order to differentiate like the transcendental functions, like trig functions, anytime the argument is something different. And in that case, it would just be chain rule. You're not actually thinking about general power rule. You can actually think about applying chain rule for really simple power rule situations too, right? Like if you thought about having y equals to x squared, and then we thought of this as being a composite function, where the exponent is the outside function and the x is the inside function, right? dy over dx would be derivative of the outside, leave the inside alone, times what's the derivative of the inside? So it'd just be 2x, right? But you're not thinking, you don't want to think about, in a case where you're just differentiating a function, you're like, hey, I can just use power rule here. Like you don't want to be thinking chain rule. It takes more mental power than just straight power rule. But just being familiar, like referencing like general power rule is whenever you have like a more complicated something being raised to a power, and in order to find the derivative, you're like using power rule for the outside function in order to complete chain rule. Rishi? Sure. Okay. So like something like this, y prime talking through, thinking, okay, outside function and inside function, derivative of the outside, leave the inside alone, and then you do want to be careful when you find the derivative of the inside. You do need to make sure you're using grouping symbols, because what is the derivative of the inside? Yeah, or 4 minus 2x, yeah. If you don't have the grouping symbol there, you don't have the correct derivative, because it would look like just 4 is multiplying, being multiplied by that first factor instead of the quantity 4 minus 2x. So you want to make sure that you're using your grouping symbols when necessary for when you multiply by the derivative of the inside. You want to remember, most common mistake for chain rule is forgetting to multiply by the derivative of the inside. There's no negative exponents. I would say we're done. No complex fractions, we're done. I'm going to put you guys into groups, and I would like you to talk through these next two. You have some options as you work through these next two. Why don't we just split it in half? We'll do 4 and 4. Okay, so turn your desk, please, so you're facing each other and can talk to each other. And go ahead and talk through what you would do, because there's options. There's different algebra you could potentially do.
Right.
Just do about 5
Yeah, we just do the chain rule.
Are you sure?
Well, actually, no, not everyone. Oh, well, actually, yeah.
Which would be to like the 1 to the 2.
Is this correct?
2 and then
Yeah, and then times
Yes.
And we could leave the derivatives like unsimplified.
Yes.
so we
As long as there's no negative exponents or complex fractions, then I'm cool with that.
2/3.
so
Because there's this one too, and there's this one, then there's this one.
Times
I guess we could have also just multiplied out. No. So for the first, like when you do chain rule, you have to take these,
To skip motion.
Would you guys get?
like the
No,
derivative
there's
of
wait,
the
why
one.
wouldn't that be the
Yeah.
same?
Wait, and this, oh, did you,
Yeah, it's like 4/30.
because what happens to the other?
Just use this two. Spawn. No, basically, no, because remember, you take the, what is it called?
This would be 2/3.
Oh, the inside?
Yeah, you have to, yeah, you multiply by the derivative of the inside.
Right, and then
Right,
times-
yeah, just forgot that.
Yeah.
Okay.
I think it's the same.
It's okay.
1
Okay, so it's the same thing for here. We just do 2 times x squared minus 1, negative 2, wait, no.
No, I guess we need that.
We're gonna remove the 2 though. Well, I guess I'm just. Oh, I guess it would. Because 2 is a constant, right? What? 2 is a constant. For the second. 2 is a constant, therefore it's just gonna stay outside. What? It's a constant. Minus 2.
Oh, you have to do 1 over.
And then you do x squared minus 1 to the power of negative 3 times 2x. 2, okay, so what is that? Minus 4. 4. Alright, did you get this? Yeah. Yeah. V.
How are we doing, you guys? Did we talk with our group members?
Sir, yes, sir.
Ideally, you guys, you want to get to the point where you're like actually talking about, like, even if it's just somebody reading the question out loud to get you started with talking with each other. Okay, instead of like, hey, I'm going to work through it and we're just going to check our answers. Like, get used to having conversations about the math that you're doing. And like, oh, I'm going to rewrite this function in this way because of this. Or, oh, I think I'd prefer to leave it here so that I could use this rule. But talking about the math. Okay, so for this first one that you guys were supposed to be working on, you could have rewritten cube root of the quantity 2x plus 1 squared in exponent form. And you could have differentiated from either. Which group, who differentiated from here? Yeah, nobody did it from here?
Well, we did that.
This one's like a function inside of a function inside of a function. Chain rule inside of chain rule, which is kind of fun.
Triple L.
But this way is definitely like the faster way. It allows you to just think about using that general power rules, right? So you're like, oh, derivative of the outside, leave the inside alone, times the derivative of the inside, get rid of your negative exponents. Did we get the same thing? Lovely. Okay, if you were like, I'm going to leave as is. I almost feel like it's a little bit of like a like personality thing, like for how certain people, like in what rules they prefer to use. I'll explain more as we get there. But like just choosing to like, I'm going to differentiate however the function is presented. Like I'm not going to use algebra to rewrite it. So then if you're differentiating from that form, you're like, okay, derivative of the outside, leave the inside alone, and then to find the derivative of the inside, you're like, I have to use chain rule again. Derivative of the outside, leave the inside alone, times the derivative of the inside. Technically, you could get rid of the negative exponent and be done here. Or for funsies, if you wanted to simplify or get it to match the answer that was there, or you're in a multiple choice situation, you would go all the way to there. For finding G prime, do we do low D high? No. We rewrote it?
Yeah.
How'd you rewrite it?
So it's just minus 1 to the negative 2.
Yeah, and then you can just use chain rule in this case. Okay. And that's kind of the cool thing about chain rule. Now that you know chain rule, you can, if you choose, to pretty much avoid like quotient rule if you want to at all times. It's sometimes a faster, more efficient, like more elegant way of finding a derivative, but a lot of times it's not. So this one I would totally think about rewriting. Right? So then when we find G prime, we're thinking derivative of the outside, leave the inside alone. Do I have to Apple Classroom, you guys? Yeah. What?
It's 2:22 p.m.
Yeah, but you're not on what we're doing.
I'm just like doing this.
Remember how you talked about you want to focus on notation? You haven't shown you've taken the derivative, and that's something that I would ding on. Okay, times derivative of the inside, right, would be times 2x. G of x is 2 times the quantity x squared minus 1 to the negative second power, but G prime is this. And then getting rid of the negative exponent. Dennis is never going to sit next to my desk ever again.
I will actually do that.
He does sit here all the time.
Yeah.
The best, I feel like it doesn't happen so much, at least it's not an issue in this class, but the best is whenever I've had where I can see like the video games happening in the whiteboard, like when they're sitting in the back row. And I'm like, hey, what are you doing? And the thumbs are going. I'm like, you're not, I don't think you're taking notes. Okie dokie. So we're gonna get into some fun problems where we're using a combination of rules. Let's go for this one. Let's do 2, 2, 2, 2. Okay. So talk through what combination of rules you're going to use for finding f prime and dy over dx with your partners. So you're just working with partners.
Okay, we have to use the multiplication rule. I forgot what it was.
It was fx times
Is it plus or minus?
Plus.
Plus? Okay, then. Oh, then it doesn't matter which order it is.
It doesn't matter.
Okay, yeah, so we use that, and then we use the other one, the chain rule. There you go. So you have like a spare pencil or something?
Why don't you go down to the tech office and ask them for one? Did you lose yours?
No, I forgot.
You can, I think they let you borrow them.
Yeah, could I do that right now?
Yeah, go.
Yours.
Oh. So I'm gonna figure out why it's
Camilla.
Say equals.
Oh, and to be clear, you guys, sorry, I know this is x cubed times the square root. That's not a cube root, just to be clear.
I got a point wrong on the test because of that.
That's tricky.
I
When that happens, I usually try and put like the little dot to indicate multiplication, but that was tricky. What's your question?
Oh yeah, no, I remember now. So we only want to put equals, or like f prime x equals if it's the final answer.
No, you would, so right away here, as soon as I start to differentiate, like applying the rules, I'm going to say f prime equals,
Oh, okay.
right? Because otherwise, if I was rewriting that, like if I was rewriting this as x cubed times 4 minus x squared to the 1/2, that's still f of x, right? So it's just as soon as I start to differentiate, I want to assign that to be f prime. No negative exponents or complex fractions.
Wait, on the AP, negative exponents are okay either?
Yeah, I just like wouldn't come up very often that you would have like a free response situation where it would
But yeah.
do like
But I got my.
let you leave it like that.
Oh wait, why is that there? What did I? Oh, I put the negative half on the wrong one.
Yeah.
Oh, it's negative and then you put a negative one.
Now let's do, okay, so this is, so we can rewrite this, right? We can rewrite this
So,
as x
maximum.
times x squared
Okay,
plus
wait, you do all.
negative
I do.
Yeah?
I'm not gonna put.
Well, there's gum on my,
We can do that
under
one.
my chair and I'm thinking.
So do you need to,
Well, don't touch it.
He's feeling gum on your senior shoes. Ew.
Wait, there's
Yeah,
next.
that's really good. Is equal to
Sorry, I made it sound deliberate.
negative 1/2 x squared plus 16 to the 3 times 2x. Yeah, so it's negative x times x squared plus 16 to the 3 halves. Okay, so y prime is equal to x
Wait, now,
times
wait, is this the right chain
negative
rule?
x times x squared plus
Did they give you one?
Yup.
Yeah.
I stole it.
Well, if they gave it to you, you didn't steal it.
No, I came to a random classroom and just took it because it was free.
Good job.
You know I'm recording everything you're saying right now.
Well,
The
it's free.
confession. I have the
right?
confession.
Well, it's free. Yeah. What do I have to confess? There's nothing to confess. It's free. I can take it. It's free. You can take it.
Mm-hmm.
I didn't get an email from Mr. Richards, but should I like?
Oh, yeah.
Oh, you don't know what time you're supposed to go either?
No. I know I'm supposed to go, but the like you said things.
Maybe
about
sh-
changing.
Oh, maybe she mixed up which group it was.
Wait,
I don't know.
Oh my goodness.
Yeah, that's
We could, if it's available, I can go to the group, right? And we're okay.
okay,
Like
wait.
takedown or whatever. It's just like
Wait,
full like
these two we can't.
baseball. Right?
Oh yeah, these two together.
if we multiply.
I lost.
But I can like ask
They're
Mr.
both
Richards.
square roots. Wait, I don't, I forget like which
Kyle?
one.
You mean Kyle?
Yeah.
Okay.
All right, groups, how's it going?
We're on the last.
You're on the next one.
Do we do?
Okay.
Shake it. Go.
Oh, you can peek if your group's done the two. You can peek towards finding H prime.
Each end.
That's a fun one.
That's
Are we done?
Oh, I think you can do it. Okay.
Yeah.
I also do.
Here you go.
That's, should we do project?
What is Dorset said about the She doesn't like powers.
What?
But okay, no, that's not what I meant to say. What did you say? She doesn't like negative powers.
I don't like negative exponents or
Yeah.
complex fractions.
Exactly.
Okay, so you guys, for differentiating f of x, this is a function that you can think of as being a product of two functions. You gotta do a little product rule. Well, bam. Okay. Sometimes it's helpful to group together like what your chain rule is, so that you could retrace your steps. Why? What would I have to simplify?
So that means that is the third line necessary, or could I just stop at the second?
Once your negative exponents are gone, boom, you're done. Now, in reality, like if this was an application of differentiation, like usually we do end up needing to get like a common denominator, but we'll talk about that more like in chapter 3. But as for me at this point, as long as there's no negative exponents or complex fractions, I'm happy.
Can we please not have a combination? Oh wait, does this mean that we have a combination of rules homework? We're gonna have like 10 of these.
This is one where you could technically rewrite it. Did anybody rewrite this to use product rule instead? Yeah?
Yeah.
How'd that go?
Probably better
Pretty
than
well.
division.
You think better than quotient rule? Well, I do a little low D high minus high D low, all over low low. And then for getting rid of the complex fraction, multiplied by a weird version of 1.
We should be yeah, I'm just gonna skip this one actually.
What? Why?
You didn't hear that.
Oh, I don't think that's.
I mean, I'm gonna totally.
What?
This one's correct. That's what I was gonna say.
You would have had a sum of fractions if you had used product rule. That's fine.
Yes.
That's fine.
Okay.
Do you want me to write it out what it would be for product rule? Okay.
I don't see how it would become that way.
Oh, should we see if we can prove it that they're the same? Okay, so if you were using product rule, you would have x times x squared plus 16 to the negative 1/2 power. So if we were differentiating using product rule, we would have first factor times derivative of the second factor would be negative 1/2 Bring that down. Negative 1/2 minus 1 would be negative 3/2. Leave the inside alone times the derivative of the inside, ends chain rule, and then plus that second factor times the derivative of the first factor. Okay, so that would be, the 2's can cancel. So what is that? Negative x squared over x squared plus 16 to the 3/2 power plus 1 over x squared plus 16 to the 1/2 power.
Yeah.
Okay, and then if we wanted a common denominator, wouldn't we want to multiply this by x squared plus 16 over itself?
Oh, that's for the 16.
Do we have to make them into one fraction? Like, do we
No, for this you do not have to. There will be a time, like in terms of applications, where you would want to get a common denominator for a derivative that's a fraction.
So we could just leave it like in the order.
You could. So I'm just trying to, because Max wasn't confident that his derivative from product rule was the same as what I had. So I'm just trying to show that it's the same thing. So you'd have what? Negative x squared plus 16 over x squared plus 16 to the 3/2. So we can see that the x squareds would cancel. And they're actually the same. Yay. Okay. This is a fun one. You have so many options here. I would actually like, okay, for each pairing, but we'll count you guys as a group of 3, and then 2, 2. I want the taller person to stand up and rotate to the group in the counterclockwise direction. So the tallest person from the group stands up and rotates to the next. So who's the tallest?
Okay, so wait, what am I doing?
And now you're going over to be partners with either Elisa or Claire.
Okay.
Claire's taller in her shoes.
Yeah, that's true.
Chat.
You decide if that counts or not. Okay, now say hello to your new grouping. No, you're going back here.
Also,
And then my tall person's coming here. Okay, and your new grouping, say hello, introduce yourselves,
Hello.
and then go ahead and find H prime. So you decide in your new grouping how you would like to approach finding H prime.
yeah, so I also did that. And then I was planning to do it this. This.
Yeah.
Oh, okay. So that's what I'm doing.
Yeah.
And then I'm just looking at
I guess you can just leave it as an effect. Yeah. I don't know.
Oh, it's Dennis's water bottle.
What is this? I
Stop making it. There's a lot of multiplying.
I bet it has hot tea in it.
Feels pretty cold.
I'm not going to
Okay. There you go.
I've never stopped using this shirt.
Okay.
This is easier. And then you add diagonals. So
I don't get it. What's the point of limiting it? What's the point of limits? I don't get it. What do you use limits for? Unless like, or like only computing them?
What's a derivative?
Yeah. What are we using? It's like
What is a derivative?
your derivative. I don't know. Maybe I wasn't like
God, bro's cooked. I'm only cooked. It's like sometimes
A derivative is a limit, first of all. That's part of the reason we care about limits, right? And derivatives is a formula for calculating rate of change.
Okay. It's each end.
name your firstborn derivative?
Or just shortly, are you saying because we haven't really done applications yet?
Yeah, I don't get what you use like other than just finding the speed of the objects and that. Like, what do you do?
I'm just gonna say hold the thought. We have a whole
AI?
3/4 to get through.
That's how AI works.
That's not true.
Well, you have to find. Well, actually.
Well, if you're trying to create,
No, because you're trying to find the slope, like internally inside of the AI. There's like a graph almost, and you're trying to find the lowest point basically.
Are you sure that's true?
Right, and to find the lowest point, you need at each step.
that's all AI.
I don't think that's
Yeah, you're trying to find. It's a mathematical model, right? AI is a mathematical model. That's all it is.
I believe you. I am not a expert on AI.
My dad talked to me in the car about for like 1 hour ago.
Alicia's
Alright,
dad talked to
goodness.
her about matrices, and then she told me for some reason, so I want to hear about matrices.
Yes.
Okay, what do you do for the
Okay. Did we leave as is, or did we rewrite as the quantity 2x minus 1 squared over x squared plus 2 squared? Did anyone rewrite like that? Or as a product? You could rewrite as a product, technically. It would actually make it more complicated because then you're dealing with negative exponents. But if you leave this as is, and you just think chain rule, right? Outside function, inside function, it actually works out quite nice. And then you're like, hey, I don't have any negative exponents. I'm leaving it.
Oh.
I mean, you could simplify if you wanted to, but I don't see a reason to simplify.
Wow.
Boom. Okay, let's get a little tricky. So anytime we are trying to differentiate a trig function and the argument is something other than just like x, you have to think chain rule in order to find the derivative. So for example, y equals to cosine of 3x, you can't just be like, oh yeah, that's negative sine of 3x. Because of that 3, you have to think chain rule. So you're thinking outside function, inside function. So dy over dx, the derivative of cosine would be negative sine. Leave the inside alone, and then times the derivative of the inside.
Wait, is that the entire?
That's it.
But is that any more like solvable than cosine? Like just leaving it as is?
Wait, what do you mean? This is the derivative.
Oh wait.
Right? Like y equals cosine of 3x would be the original function, and then the derivative would be negative 3 sine of 3x.
I learned.
You guys, we are at the phase of like, to me, like limits, you're like learning letters. We are starting to put words together, right? We have to be able to spell words before you can write sentences or write essays, right? My point being, you are at like the ground level of calculus here. We have not gotten into interesting applications. We will get into more interesting applications.
That's right, and I believe so too.
What's up?
What the other reason? I liked your analogy that it's the building block of this.
Okay.
So yeah, I wasn't.
Okay.
I understood it. Thank you.
Okay. Let's go. I want what did I do? The tallest person? Let's do the shortest person. Oh no, then it'll just be matched up again, won't it? Not necessarily. Let's have the tallest person of this new grouping move clockwise, please, to your new group.
Okay. Alright,
It's just the same for you people.
Okay. On this page with your new grouping, go ahead and try and find the derivative of each of those trig functions using chain rule.
I don't remember.
Man, I have nothing.
And if you don't have the derivatives memorized yet, this is a good time to practice them.
Yeah. Yeah.
I'm just gonna.
I just did the first.
Okay.
I think it's gonna be on the today.
So that's
I'm not gonna do it Friday, because I haven't done the.
Yeah.
the quiz yet.
Yeah, I think that's
How long is it?
a while. An hour and a half.
Okay, that's it.
Yeah. But it's there's some of them are just yeah, but it's
One half equals square x over 2.
Yes.
they're like medium.
So.
Is this?
Wait, is it something like?
No, why is it square?
Wait.
Wait.
Is it double chain?
Oh wait, no, you don't. No, you don't. It's just gonna be 1/2.
Oh, for C.
So.
Yeah, it's just gonna be 1/2. 1/2 secant squared x over 2. Because 1/2
4
is
sine 2x
Even though x over
Do
2
you get
is
that?
sine squared. What am I supposed to do with this thing?
I'm thinking double chain.
Yeah, I know.
But that's annoying.
That's annoying.
Yeah.
Holy, there's no way I'm not. Wait, there's no way this is not like on the cheat sheet, right?
No, there is no cheat sheet.
For Calc AP, but like no, like the test AP exam cheat sheet, no?
There is no cheat sheet
There's no
provided.
cheat sheet for AP exam.
No,
No?
no cheat sheet, my
No,
friend.
Like the equation sheet, that's what I meant.
None.
No
Zero.
equation sheet?
No.
He kind of spoiled us. He got like.
Dude, that's the same thing in physics.
And
as
phys-
well. Oh,
I
yeah.
know.
Wait, what is this? This is
Yeah.
actually a scam.
It's just too.
Yeah.
It's literally a scam. It's not a scam.
Okay.
Hold on. Oh my god. We need to have less people take math. We need to have less people take math. Otherwise it's too hard.
I got a whole mess of science.
Well, oh, yeah,
Did you
Oh,
have?
wait, did you get two? Wait, what?
Yeah.
Oh, yeah.
You do 2, and then it's like what's in there, and then for that it's like.
Yep, I'm just gonna do this.
Oh, you're right.
Sine 2x. Cosine 2x times 2.
It's secant x Canada.
Just leave that.
No.
Unless you were trying to like remember it in at least.
Well, but it's only one.
Like, I was like thinking, and sine part, so like you should set a half, and this is really total.
Okay.
Yeah,
Okay,
so
okay, yeah.
Dude, learning is not
Maybe negative 1/2 because it's right, minus 1. 1/2 minus 1.
Oh, yeah, yeah,
You have to do a secant, what is that? I'm just gonna do some goofy, like secant. Secant tan.
Okay.
Like, how am I supposed to? Secant here.
It's okay. It's fine.
No, wait, hold on, this actually might be a problem. If I have to learn all of these, this might actually be, I'm just now realizing how big a problem this might be. Wait, hold on, this might actually be a big problem. How am I gonna memorize all these?
It's okay then.
Well, remember, all the trig functions that start with C have derivatives that are negative.
Super helpful. Thank you very much. That applies for all like one of those.
Maybe 2.
Well, yeah.
Oh, many.
Dennis,
Okay, fine.
how many trig functions are there and how many start with 3? How about half of them and then you know the other half would be
Yeah,
positive?
but I don't know the inside. Like I only know the sign. It's like half of the problem. Actually, that's like 1/2. No, that's like 1/3 of the problem. No, like literally 1/4 of the problem.
You can do this, Dennis. I know you
I
can.
think I'm good. How do you take that 3? If I'm good at it. How do you get the 3 out?
Oh, you did chain twice, because the 3 is like.
Okay,
Yeah, some of these
I
were
forgot the
nesting doll status. Functions inside functions inside functions.
It's just 1/2. Yeah. Okay, I'll just go through. Times 1? Okay. Did you get this?
Well, would it be secant x in there and then secant x?
Oh yeah, you're right. Because you have to. Yeah. Because you have to. Oh my god. No way. We have to do that, right?
Dennis,
And
you're like whining a lot today.
Today's like, if we're gonna have like 5 of these, oh my god. Dennis, let's go on the couch. This is You need to crash.
All of us line up.
Okay.
I need to memorize mine.
Oh my god.
Cotangent.
Wait, so is it like
It's cosecant.
I'm sure this is gonna be much easier once I memorize them.
They also like kind of the functions that are like co-functions of each other, like it kind of matches up, right? Like derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cotangent would be negative cosecant squared, right? You know what, Dennis? I feel like I could tell you were getting a cheat sheet and you would still
I am.
act like
I
a
am getting
no.
Man, I need a Lawrence. You're right about that. Cheat sheet.
All right, you guys, let's check in on these. So, little chain roll for the first one. And also, just by doing them and practicing them, you will become familiar with them. So, really, that first line you could have left as the derivative, but if you want to clean it up, make sure you're using grouping symbols around the argument of your derivative. Tangent of x over 2 is the same as tan of 1/2 x. Sometimes people need to see like the x over 2 written as like the 1/2 x in order for them to think about differentiation. But derivative of the outside, leave the inside alone, times the derivative of the inside. Is that okay? Okay, next one, function inside of a function inside of a function. Chain roll and chain roll. So, or, did anybody write that as a product and use product rule? Because you technically could have done that, right? Sine of 2x times sine of 2x. You did that?
Yeah.
That works. But chain roll inside chain roll, right? Derivative of the outside, leave the inside alone, times the derivative of the inside, which would be chain roll again. So derivative of the outside, leave the inside alone, times the derivative of the inside. But again, you could have written that as sine of 2x times sine of 2x and used product rule. And that would have also worked out.
This two comes from the second. Oh,
Yeah, from the second chain roll. Right? Derivative of the inside.
I will not want to push this until it goes out right now. Wait, okay, there we go.
Dennis, we have a long road ahead of us, my friend.
No, I'm
This is not the time. Chain roll is not the time to start complaining.
No, this is fine.
This,
In general,
I actually think I made your life easier today by showing you chain roll.
Well, yeah, but it's less fun. Because, like, in regular, like, stuff, you don't have to, like, because there's a lot of, like, remembering going on here. What? You have to, like, memorize a lot of the rules, and it's like, yeah. That's not fun, is it? No.
It's not?
It's not. No, memorizing things is not fun, because you have to, like, this is not language, this is a math. Like, what do you know here? Why is you okay? What do you read? I don't like glasses. This is not a lip glass.
Do we have questions on any of these? Okay.
Wait, sorry.
Oh, Rishi.
Where did the 4 come times 4?
Wait, yeah, what is 4 come
To finish chain roll.
inside the 4x.
Because to chain roll twice, right? So, because it's a function inside of a function inside of a function. So derivative of the outside function, leave the inside alone, times derivative of the inside function, but we have to use chain roll to find the derivative of cotangent of 4x. So derivative of outside, leave the inside alone, times the derivative of the inside.
I swear, I forgot this.
Okay, you gotta finish the chain rule.
Wait. Oh.
Yeah.
Okay, I get it, yeah. Wait, yeah.
Okay, this time, the person with the longest nails in the group is going to rotate to the right.
Oh, good job.
Maybe I should have done the shortest nail. I did longest nails this morning and there were some girls that had some long nails in there.
I did ones for different hands
These
because of the
Sorry.
guitar.
Ah, so you can
Would
choose
you name your
which you
first
want.
derivative?
No.
Or just average
How
it out.
about
Nails
tangent?
are longer.
How about power rule? Would you name power rule?
No.
Yo, little power rule, how's it going?
Nails longer.
You bet.
Well, it's pretty important.
All right, say hello, introduce yourself in your new grouping. Okay, in your new grouping, find the equation of the tangent line to this curve at this point, and then determine all the values of x on the interval from 0 to 2 pi at which the graph of, this should be f. We'll call this f of x here. Let's call this f of x. At which the graph of f has a horizontal tangent line.
Okay, so we just like find
Oh my god, not this one.
So, all I know is we have to derive first. I guess it's
Oh.
Okay. Wait, we had like cosine sine like rules before. What was those? What were those for limits?
Like the derivatives of sine and cosine?
A little confused.
Yeah, I'm a little confused here. What do we do now?
You are differentiating.
Yeah.
Okay.
Oh, those were ones were for limits. Or like, yeah, I don't, you know what? Because I remember we had like sine and cosine. We had to do something with them as well. But I don't particularly.
We talked about their derivatives.
So this is the same thing as that, right?
when the x
Okay, cool.
is
Okay,
pi.
just making sure. Okay, then I have to
Oh, wow.
divide it by
This, so it's f prime is pi,
um.
2 cosine pi.
Okay, two cosine. Okay, 2 cosine x plus negative.
Here remembers the units.
No, negative 2 sine.
I don't remember the units.
No, negative 2 sine 2x.
What's negative 2?
Is that correct?
Cosine starts at 1, right?
Oh, I wasn't there
What?
yet.
Yeah.
Oh, you're thinking about its graph?
There you go.
Yeah, and like,
And then we'll pass through 0 and then go down to its lowest point, and then back up through 0 and then finish at the highest point
cosine.
for cosine.
Really? I thought it started at like at 0.
No, sine passes through the origin.
Okay, so now we just do the pi.
Oh, that makes sense, right? Okay.
Wait, we literally have no idea why I just walked through all of that shit.
What you did?
No, I plugged in X for F of
Oh,
X, but we haven't. Okay, that's
And 2 pi is 0.
not my premise.
So, sine is this is minus 0.
It's okay. It's okay to
It's
It's okay. It's okay.
No, just whatever.
Okay, don't worry.
This is cool.
Still 0.
Zero.
Getting the slope at 0.
Cosine and pi. So think about where's pi on the unit circle?
It's on the
Over here, right? So what is that point on the unit circle that corresponds to pi?
cosine
What? Where's your?
0, 1. No, minus 1.
minus 1
Minus
comma
1,
0.
0.
Cosine corresponds to the x, so
Wait, pi
cosine of pi is actually
cosine
negative
of
1.
pi is negative.
Yeah,
So minus
You could also think of it
Minus
from the
this.
way you were talking about it. Cosine starts high, right, at 1. And
What's
so
sine of
half a
two- what's sine
period
of two- what's sine of
over,
two
it would be
pi?
down at its
What's
lowest
sine of
point
two
at
pi?
negative 1.
Right. Okay. Yes.
Okay.
That's what I'm saying, it's cooked level, bro. This is cooked. It's cooked.
It's y minus 1
Right.
equals
Okay, so with
x minus 2 times x
y, which is
minus
one.
pi.
Wait, it's 258 is negative 2.
Great. How about our
You know what, I'm still
Thank you.
Yeah.
So that's like a little 1/3.
Come on.
All x values from the interval 0 to 2 pi is to graph x up horizontal. Just to say the zeros.
So next one. Wait, what are we doing? It's one.
Wait, it is.
One.
Oh.
Literally says it's
You're right.
right. I'm sorry. Yeah, see, I'm trying to let you cook on this one.
Yeah.
I don't want to subtract. Well, actually, I
But it
guess
has
I
to
can
be
subtract.
in,
This is just
the
has
first
to be
column or
1
Yeah.
plus 2 pi.
so it's
Which was 1 plus 2 pi.
wait, it's
There you go.
3 and
1 plus 2 pi.
Wait, this is the answer.
No, 5 and 4
I don't know how to solve
Yeah.
for 0 in the
See,
Yeah.
well,
I don't know why this is.
yes,
In other moments, would you?
No.
Yes, I do this. In this moment, in the moment,
It's
it's
just
cosine.
pressure on it. No, yes.
Yeah, in this moment, it fails.
All right, you guys.
Oh, 5%.
Let's check it before the bell rings.
I would sooner name him Dennis.
So for finding f prime, okay, just knowing the derivative of sine is cosine and then doing a little chain rule, right, for finding the derivative of cosine of 2x. F prime of pi, so remembering cosine of pi would be negative 1, sine of 2 pi would be 0, so f prime of pi is negative 2. Pop that into point slope form for your equation of the tangent line. And then horizontal tangent lines, right, horizontal lines have a slope of 0. So looking for where f prime would be equal to 0, use a little trig identity there. If it was calculator active, you could just find the points of intersection using like Desmos or your graphing calculator on the interval from 0 to 2 pi, easy peasy. Solving analytically, you'd want to use the identity. So for cosine of x equal to 0, you'd get pi over 2, 3 pi over 2. And then for sine of x equal to 1/2, you'd get pi over 6 and 5 pi over 6. All right, you guys, I'll be sending out information on the quiz soon.